So my goal in this exercise of technology exploration was to take an existing storage subsystem and enhance it in ways that we would like. Give it replication, give it all the nice features and better capacity than it originally had. So there's a lot of reasons we want to do this. Economics are definitely a good reason. Right now, we all have to kind of hold back and not spend so much. So keeping the value in an existing system is a good idea. Or maybe you have multiple different kinds of storage subsystems with different nuances. You might have an EMC or an NetApp or an IBM, and you want to consolidate it to one single storage subsystem. You could also create some flexibility in that storage system without discarding its value. So there's another feature that COMSTAR as a product will grant us, and it really is about protocols. We can connect anything to it over anything. And there are no other products out there that really are striving for that. I think COMSTAR is going to do that. The other real good reason for reprovisioning an existing data store is to grant us data mobility between those stores. So we can move data around the back-end FC systems with ease. So why would you choose COMSTAR? I can think of quite a few reasons. It is totally comprehensive. It covers every angle. I don't see anything it doesn't cover yet. It's an awesome toolbox. It grants multi-protocol, multi-path, current initiators to any of its hosted LU targets. You can use FC, FCOE, ISER, iSCSI, InfiniBand, SAS, I just heard, and others that I haven't even mentioned. But these are the primaries. You get ZFS, software read, variable blocks, disparate device support, integrity, compression, replication, import, export, send, receive, snapshots. Wow, that's a mouthful. There's a lot of technology in that one little box. You get increment caching. You throw as much DRAM as you want. It's commodity. It's cheap. You got write SSDs, read SSDs. You get AES. You can do async, sync, replication. You get the entire NAS suite. Phenomenal. Obviously, it's much more than a protocol gateway, but you still get to use it as a gateway if you want. And my favorite part, this is cool. You can actually take the thing, virtualize it, and use it anywhere you want. You can develop on it anywhere you want. You can test it anywhere you want. You can send your data anywhere you want. Encapsulate it. Beautiful, nice product. You can't do that with an EMC or an NetApp, or it's not possible. So I know most of you probably know the guts of COMSTAR, but I thought I would just throw up the one little element of COMSTAR that makes sense. And from a 30,000 foot level, it really is 4 basic service layers. You get your LU provider, so it's going to be your your command block descriptor, and everything's handled through that LU provider. It does a little bit of virtualization for you. It's a powerful little engine. It does most of the work in COMSTAR. Then you get your SCSI target mode facility, and basically it's truly the gatekeeper of the product. It handles what can see what. And from a SCSI perspective, it's the controller. It does the online and offline states. It's a state machine and handles most of that work. And finally, you got work providers, and it's completely separately intact. It completely isolates all protocol noise that you'd have to deal with. And finally, of course, we can manage it through the agent facility and the API set. So let's look at what a provisioning architecture would look like. Basically what we're trying to do is we're trying to take a COMSTAR head, connect it to some disparate FC storage arrays. It could even be a JBOD for that matter, it doesn't really matter. We're just going to reprovision existing storage. We're going to connect it to multiple protocols, and we're going to expose LUNs that look the same to all of them. So whether you're using InfiniBand, whether you're using iSCSI, it really doesn't matter. They all see the same LUN, which may not be the case with other products. So within the architecture, there are some basic objectives, and what we'd really like to see to make it worthwhile doing, because if If it isn't worthwhile doing, we shouldn't be doing it. So if we can't get maximized I/O, we're not going to do it. If we can't get throughput performance, we're not going to do it. We need to be able to optimize that disk storage capacity. Because typically older systems, whether they be 2 years or 3 years old, don't have as much storage. And for that matter, you really don't want to upgrade them any further. You really want to migrate away from the older systems. But this gives you time to migrate to an S7000 series, for example. So you can take the existing arrays and optimize the disk storage capacity. You can enable the new desirable features like replication snapshots, which it probably doesn't have. And if you did want to enable those options, you have to license them, and they're quite costly. You really need to create system autonomy. You really need to be able to move data around the systems without worrying about what they're running on. And today with proprietary systems, that's virtually impossible without the capability. You need to really reduce costs, and you need some protocol tiers. I don't want to have to connect FC-based hosts when they only need high schedule level throughput. And most places have those same issues today. So within that primary objectives, performance is number one. We can attain that in several different ways. RAID 0 stripes on the existing RAID makes the most sense. Because it's the lowest level of storage, we need to optimize that slow device with RAID 0 stripes. Within those RAID 0 stripes, we can aggregate them to a RAID 2 array. So we take the RAID 0 stripes and create RAID Z arrays, which gives us the availability. DRAM is obviously going to optimize the engine as much as possible, and we could consider read and write cache SSDs if the throughput is really required. I find that most environments don't. In a general environment, you don't need that much throughput, but it certainly at a cost level would be a good idea. If you did use the SSD solution, you could probably attain tenfold the performance of the existing system. I'm seeing 1,500 IOPS on the existing systems, and 10,000 IOPS is easily tenfold. And the throughput's going to be there, because we're using RAID 0 stripes. So to get a visual of that, you can kind of see that the RAID DP world of RAID 0 aggregates makes sense. If the externalized storage system has RAID 0 stripes, those are deep pipes. Those pipes can take a lot of data, and large data. So when they're at the end of a RAID 0 pool, they'll pick up as much data as you can throw at them, and it's not going to saturate that RAID Z stripe. So within the RAID Z I/O stripes, you can pretty much throw a lot of I/O at it because you've got a lot of devices handling it. So it'll keep streaming that I/O. It's not going to bottleneck. Your existing old device can handle quite a bit. And then if that's not enough, let's aggregate the entire thing. Take those RAID Z stripes and multiply them until you have enough I/O. You could also take that same RAID 0 stripe and with multiple FCs, if you have 3 or more, you could actually set it up where you're not going to have any single system failure to bring the whole thing down. So you can take the entire FC unit offline, it will continue to run, and bring it online. Pretty good little feature. We need to optimize that storage capacity, and obviously there's many ways to do that. The ZFS grants us the ability to compression and leverage CPU sources. Today's CPU is going to easily take the workload, not a problem. We can logically manage snapshot retention times. And a lot of times we think of snapshots as, oh, I'll just throw a snapshot on and away we go. If you do that a lot, I'm pretty sure that you're going to run out of space. Because there's so much delta between snapshots. And I've actually seen it, because I've been using it for over a year. It will run out of space unless you add space. So unless you like adding a lot of disk, you need to manage the snapshot retention time. And there's several ways to do that. We'll talk about that in a few slides. One particularly bad thing to let happen is noise-based I/O should never exist on a snapshot. And noise-based I/O is simply temp files, swapping files, they're just noisy, and there's no value at all. They have no permanent data retention at all. So those should be isolated outside of the snapshot window. And another thing that really grants us good capacity management is thin provisioning. And we all seem to think thin provisioning is something that we place on the storage subsystem, and it's something bad because if we run out of space because the back end didn't have enough space, we don't get alerted to that. And I kind of find that strange because I would actually monitor the back end space, not the thin provision space. So that argument is kind of poor. If you monitor the back end space, you're going to know if you're low, you're just going to add some more disk, and it's going to carry on. And as fast as any part of the system needs that storage, you just add more disk. So there is no reason to say that thin provisioning doesn't work. It certainly does, and it also gives you a lot of other capacity availabilities. For example, if you took a scenario where one consumer was consuming too much space and you need to reallocate, well, you don't have to do anything at the OS level, so there's no OS downtime. You add this storage. You didn't have to move it. That's even worse if you had to move the storage somewhere else. You're going to consume fiber channel bandwidth. You're going to consume network bandwidth. Thin provisioning is a good thing to do all around. Can't hurt you. So the whole concept it wraps around a couple of features that I like. One of the features is to actually move LUs around storage units. And I don't know of anyone else doing this yet, but there probably is somebody out there trying this out. I've seen them do it on iSCSI, but I haven't seen them do it on COMSTAR. So what we're going to actually do is I'm going to walk you through a very detailed COMSTAR setup. And it has two emulated storage heads, because I simply can't run fiber channel SANs in my basement. And then it has a COMSTAR gateway attaching to them. So we're going to set up these two fiber channel emulated boxes with COMSTAR. Then we're going to attach to it with the gateway. And we're going to provision some storage on it. But we're going to provision it over two multi-protocol paths. So we're going to have a multi-protocol connection, and it's going to be dual tap. And then what we're going to do is we're going to destroy one. We're going to move into a second set of storage units, and we're going to add a mirror between these two, synchronize it over. But we're going to also destroy that mirror. But all the while, we're going to transfer some data across it. We're going to see what happens to those consumers. Now, this is a frame stop demo, it's not a video. The main reason I did that was I didn't know how long it would take if I went with video. This is a much easier solution to work with, thanks to Coraline. Okay, so this is the first of the two emulated heads. Okay, so we're going to create a ZFS-based store, 100 gig, 64K blocks, and we're going to provide a LU with COMSTAR. We're going to create a gateway to associate that LU. We're going to create a view of the LU. We're going to go over to the COMSTAR gateway. And on the COMSTAR gateway, we just need to retrieve one of the FC initiator build line names. We're going to create a membership to the host group, gateway 1, with that build line name. Then we're just going to configure that new connection. So we now have a provisioned LU from RFC host head. And then we're going to create a pool based on that provisioned one. And now we're going to reprovision. So we've attached to that head, got a fiber channel connection to it, created an LU with it, provided some ZFS storage. But there's something in that command that's different. It's 1 terabyte instead of 100 gig. So it's thin provision. we're also going to turn on compression. I think that gzip actually works over a lot of processors. I did it recently, and I didn't attain CPU bottlenecking on a quad proc 9550 Intel. It didn't even reach half, so I'm not sure. I probably didn't push the server enough. That's a lot of testing to do. I didn't reach those levels, so I'm quite satisfied that it worked quite fine. Okay, so we need to create a view to the one we just created. And this view is for the consumer, and this is going to be a VMware ESX engine that's going to attach. We're going to use iSCSI in this first instance to grab an IP, create a target portal group, because we only want this one interface to talk. We create a iSCSI target in COMSTAR. Define an initiator. I got to go grab the initiator name from the VMware box. So you see it right there. And we've defined an initiator and a target. We need to create a group for that to connect to. And here we've refreshed the ESX server and we have a connection. 1 terabyte line down at the bottom. Here we've created a VMware VMFS store, VG1 C star is 1 terabyte. The host has no idea that it's 1 terabyte. We know this. And we can see that we have indeed defined it and it's working just fine. So I'm not satisfied with one connection. I think we should have two. So grab the worldwide name from the fiber channel adapter on the VMware host. We grab it and we define it, and lo and behold, we now have a connection to it as well. So we actually have a multi-protocol, multi-path connection using open source products. I don't think this is possible with any other product. So right now we're just going to create a clone to create some data flow in the background. And now it's time to find our second FC host with the emulator. So let's quickly go through this part. Same steps. Grab that worldwide name from our head. Go back, create view. And lo and behold, we can now see that we have our first definition and some extra drives up there above. And we create a mirror. It's very quick with the fiber channel side. No bottlenecks there. VMware, on the other hand, is a different story. And now we delete it. So essentially what's just happened is we created the storage on one side, mirrored it over, deleted it, and it should be on the other side. And hopefully our consumer didn't know. The consumer did see something. It saw some loss of bandwidth while it was mirroring, but it didn't go down. So our consumer didn't know about it, and we have high availability between a COMSTAR engine, multi-protocol, multi-path. You can see it transferring there. What's really cool is I actually did 3 clones. And you can see the size of the clone, that's 16 gig. That's the first clone. Second clone, even a little bigger, 16 plus 12. And during that transition, remember we turned compression on. So we now have 50 gig consumed on the original fiber channel system, because it doesn't have any of those features. At the very bottom line, after everything was cloned over, we got 8 gig of consumption. We're going from 50 to 8 gig. Truly incredible. Another good objective is to create autonomy. Autonomy basically grants us the ability to run the storage system on any target, anything we want. If it's an XVM session, if it's a VMware session, it really doesn't matter. It allows you to move around. It also allows you to transfer your file system anywhere. And that's been shown in multiple ways outside of this presentation. It also grants that freedom from vendor lock-in. And an interesting story. I was reading on some of the VMware forums where one of the consumers was looking for drives for a particular vendor, I won't name the vendor. And these drives were available from the vendor for $2,500. And the same model drive was available elsewhere for $1,000. But the only separator between those drives, since they're actually the same manufacturer, same models, was firmware. So really, you're paying for IP only, firmware. And that's a good example of vendor lock, because now if you wanted to upgrade your spiral channel storage array from private vendor, you're going to pay considerably more for each disk you put in. That doesn't happen with COMSTAR or OpenSolaris or 7000 series. So this next little one, provisioning the ability to access some or all of our storage in an external reservation instance, is somewhat hard to grasp. All we're really doing here is moving the storage out of its existing confine to another entity. That entity is a VM, and it's completely isolated. So you can work with it all you want, from all aspects. The other thing we need to do to make sure that encapsulation or autonomy works is focus on protocol transports that are virtualizable, like FCOE, iSCSI. FC is somewhat virtualizable, but there's too many issues with it. It's hard to constrain. And that world of autonomy grants us the encapsulation capability. So we can move storage around in a complete entity, and it isolates us from the confines of hardware. So I'm going to go through the demo of that, see how that works first. All right, so what we're looking at is, this is a production certification test environment. It's real, it's active, and it works. It works very well. It has some LUNs provisioned on the right-hand side there called SS1, ZRP1. And those are provided on X4500 using an iSCSI target. So one of the instances or virtual machines on this VMware environment is displayed here, and you can see it's active and available, and it's running. The TPC5 is the host we're going to follow, and it's attached. You can see the iSCSI connection. It's attached with two logic iSCSI adapters. And what we're going to do is we're going to replicate this storage to another box. You can see the LUNs there, and you can see the snapshots. These are automated snapshots, and what they do is they generate a grandfather, father, son format. So remember I was talking about don't willy-nilly snapshot because it's going to consume a lot of space. And you can actually see some of that space there. You can see that the yearly snapshot, December 31st, 51 gig. And then each week after that, or month after that, it grows a little bit and then it rolls up again. So if you let the snapshots walk away, they will consume all the space. And you'll have a bigger problem. You can see the definitions of these iSCSI targets. This is within Solaris, and this is the standard iSCSI target. It has a backing store that's ZFS based and a GUID. The script that runs the replication, ZFS daily. Now we're on the target system, WCBSS2. This system's unique because this system is an actual VM. So it's virtualized, and it's running on top of ESXi, VMware. You can see that the mappings on this side are different. they're mapped to clone directories. And they're not existent at this moment. So we're going to create them. So we're going to clone our snapshots, create those LUNs. The LUNs are now defined. And we're going to rescan the isolated target on the ESX box, which is going to connect to its own VM, WCBSS2, and it's going to give us volumes. Talk about rampant violations of layering. So we have a host serving itself. What's really cool about that is it's portable. I can bring it in. And you can see now, when we're examining the same LUs that we had on the X4500 physical box contained inside another server, which has nothing to do with that physical hardware. And it's running the same instance of VM. That's pretty cool to me. I thought that was useful. There are reasons we wanted to use storage encapsulation, and you can see some of them. If you had some development crew that needed to work on a specific environment, you could actually clone it off in a few minutes, throw it onto a standalone box, and they can carry it away. They can take it anywhere. And all they need to connect to it is a web browser or a client instance on a laptop. So the autonomy is pretty powerful. Another good reason is disaster recovery. That's probably the best reason. I can take a $5,000 box and I can put a lot of storage on there, especially if it's compressed. As a matter of fact, I'm compressing this 12 terabyte environment onto a 2 terabyte environment. Of course, we don't get the performance, nor do we care. It doesn't matter. It can be expanded out in Encap. Lots of other reasons, testing, demonstrations, audit compliance. You might have some testing going on in there that's damaging development. Systems transitioning, where you move data in, and time capsules. You can actually take snapshots of your environment, package it away, and move it somewhere.